In this video, we will study how to model interaction between two independent variables and then how to interpret these interaction effects. So here's a data set with sales as a dependent variable and price and advertisement expenditure as our independent variable. Let's start by modeling this relationship using multiple regression. So we're going to analyze, fit model. Our dependent variable is sales, and then we move price and advertisement to our independent variables. And let's run this. What we see is that the sales are positively associated with advertisement expenditure and negatively associated with prices. And both these effects are statistically significant. And then let's note the R-square adjusted value as well. Our adjusted R-square is 0.83645. What if we were interested in seeing if these two independent variables, price and advertisement, have some joint effects? In other words, do they interact with each other? For example, does at various price points the impact of advertising ad expenditure change in affecting our sales? So the way we model this is not only will we have these two independent variables by themselves, we will also create a third variable which will be essentially price multiplied by our ad spending. To create this variable, let's go back to our data table. And now again, we'll generate a new column, and then we can say the column's formula is essentially price multiplied by advertising spending. And we click on apply. And then let's rename this column as price times advertisement and click OK. So now we have this new column, which is the interaction of price and advertisement spending. Now let's run a regression model including this new variable along with the other two independent variables in our regression. So we go to analyze, again fit model, and now sales is moved to the independent, and then let's select all these three and then add them to our X variable. So now we have price, advertisement spending, and price times advertisement expenditure. Let's run this. We can see that all three variables will be statistically significant. In fact, the log word tells us the relative importance of each of these columns, and interestingly, the interaction effect has a stronger log word than just price by itself. The second thing to notice is that the adjusted R-square for this model is 0.97, whereas the adjusted R-square before was 0.84. So including the interaction term has definitely improved the goodness of fit of this model. And now let's examine the results. What we see is that the effect of price now is 175. So that would say that an increase by $1 of price would be increasing our sales by 175. Now again, the unit of sales was 1,000, so that's how you would interpret that. For ads, the coefficient is 19.68. So this may suggest that increasing ad spending by $1,000 would increase our sales by 19,000. However, there's an interaction effect as well, and in truly interpreting each of these coefficients individually, we'll have to factor this in. So how would we interpret this? Let's see first by examining the equation and then trying to distill the effect of each of these variables on sales. So the equation that we have just estimated is essentially that sales are a function of our intercept plus B1 price plus B2 advertisement plus B3 price times advertisement. So applying partial differentiation, again, what we're examining is the effect of each of these variables on a dependent variable, holding everything else constant. So essentially, if we want to study the effect of ad spending on our sales, we would take the partial derivative of sales with respect to ad spending. So we will do sales, del sales by del ad spending. And then now notice this is a constant, this term goes away, this term goes away. We have our B2, plus we also have B3 times price and advertisement here. So when we differentiate partially this expression with respect to ad, we get B3 times price. So applying the context of a regression, what we just estimated is that the partial effect of sales, of ad on sales, is essentially the coefficient of ad spending, which is 19.68, plus B3, and now B3 is our negative 6.08, so we have minus 6.08 times price. So to truly see the effect of ad spending on sales, we'd have to fit in a value of price, and then we can see what is the effect of a unit change in ad on our sales. So the convention is that we would now insert the mean value of price here in our analysis, and then we can see how much is the impact of ad spending on sales, factoring in the interaction between sales and price. So let's look at the mean value of price, and for that we can go back to our data table, and then we can go to analyze, and now we'll look at the distribution. So we can actually look at the distribution or mean of both our independent variables. So I'm going to include my price and ad spending as Y columns and click OK. So we see that our mean of price is 2.5. So what we can do is we can insert 2.5 here, and then we will see the true effect of ad spending on our sales. So 19.68 minus 6.08 times 2.5. And then plugging these in the calculator, we get an answer of 4.48. What this number tells us is that an increase of ad spending by a unit will be changing our sales by 4.48 at the mean value of price. In other words, increasing our ad spending by $1,000 when the price is $2.50 will increase our sales by 4,480 units. Now, of course, if we changed the value of price to a different value, we would get a different answer. So if we had a price at, let's say, $1, then we would have had 19.68 minus 6.08, which would have been 13.6. So an increase of ad spending by 1 unit would have increased our sales by 13.6 units at the price being $1. So again, the interaction effect tells us that there is a relationship between the two independent variables, and the value of one variable is impacting the net effect of the other variable on the dependent variable or outcome of interest. So interaction variables are also used extensively in business and economics, especially when you're studying relationship between two independent variables and how they would jointly impact the dependent variable. We could have also done this analysis for price, keeping ad spending the same. I would have taken the partial of sales with respect to price, then we would have had B1 plus B3 times advert. Then we would have to fix a value of advertisement and then calculate the effect of price. So now notice, as a result, we cannot just look at the individual coefficients that we get and claim them to be the effects of our price on sales or ad spending on sales, because the moment we incorporate interactions, we have to factor in this also to see the true effect of our independent variable on our dependent variable. So this quick calculation is very useful in studying the true extent of how ad spending affects sales for a given value of price.